Hey guys, I hope you're having a great week. We're going to get started on our lesson about expressions today. These are our standards of excellence. A few more. Our learning targets. All right, so what is an expression? An expression differs from an equation because an equation has an equal sign. Okay, I don't really like this example because this whole thing does have an equal sign. So if you have an expression like 2x plus 4, that is an expression. There's no equal sign, right? As soon as you put an equal sign on it, this expression has just turned into an equation, equal sign equation. And when you have a value, you can actually figure out what the value of this variable is. If they don't give you an equal sign, if you just have this expression right here, you have no way of knowing the value of the x. It could be any number you can imagine, okay? So this is an expression. So they're showing that the part of the equation that's the expression is 4x minus 7. The entire thing would be an equation, okay? All right, so expressions are made up of different terms. Actually, there could just be one term. So let me write this. So let's say I have 2x plus 6 minus 4y. This whole expression is actually made up of 3 terms. So terms are separated by plus and minus signs. Well, the first one obviously doesn't have a sign in front of it. It is a positive term. So our first term here is 2x. Our second term is a positive 6. So that plus sign separates these terms, but that sign actually belongs to the 6. It makes it positive. And then our last term is a negative 4y. That minus sign separates this term from the rest, but that sign still belongs to this whole term. Okay, so 3 terms, 2x, positive 6, and minus or negative 4y, same thing. So 3 terms here. All right, so here we have a term 4x. We have a minus 7 or negative 7. It doesn't matter what you call it. And we have a positive 5. This is an equal sign. Like I said, I should have changed that whole example. But anyway, there it is. All right, so within this expression, here we have an expression. There's no equal sign. We have how many terms? We have 2 terms. So the first one is a term, 4x is one term, and then there's a plus symbol which separates 4x from 9. So 4x is a term and 9 is a term. So you need to know all of these terms over here. I'm just going through them one at a time. So a variable in math represents an unknown number. So we don't know what the value of x is, but we do know that 4 is being multiplied by an unknown number, 4x. A constant is a term that is not attached to a variable. So the positive 9 is a constant. And if you do have a number that's multiplied by a variable, that number, that leading number in front, is called the coefficient. Okay, so that's all of these words over here. Variable, a symbol that stands for an unknown number. A coefficient is any variable that has a number multiplied in the front of it. That is your coefficient. A constant is a number that is not attached to a variable, and terms are separated by plus and minus signs. These are all examples of algebraic expressions. Okay, so you can have just one term to make up an expression. There's no equal sign, so 5 is just an algebraic expression. X is by itself, it's one term. This whole thing is a term. Why is 3xy squared one term? The reason is because there's no plus or minus signs in there. So this whole thing makes up a term. And right here we have 3 terms. This expression is made out of 3 terms. 5a squared, positive 2xy is the second term, and the third term is positive 3. These are all individual terms. All right, so these are more examples of, these are examples of like terms. So what makes terms either like each other or unlike? They're not like terms. Well, it depends on the variables and the exponents. So here we have 5x squared. Well, even though the 5 and the -9 are not, they're different, totally different, the x squared makes these two like terms. It all depends on the variables and the exponents. All right, 2a, b, c, our variables are all a, b, and c. Well, this one also has a, b, c. So 2a, b, c and 10a, b, c are like terms. All right, both of these terms has a y squared attached to it. Even though the coefficients are different, these are still like terms based because of the variables in the exponents. These are not like terms because this has a variable y and the first one doesn't. These are not like terms, even though our exponents are the same, the variables themselves are different. And here, these are unlike terms because this x does not have an exponent of 2. So I hope these examples and non-examples make sense to you. All right, so all of these have coefficients. So it's whatever is being multiplied by a variable. So the coefficient in the first example is 1/2. The coefficient in this whole long term is 16. The coefficient in this long one term is 9. And actually, you might think x doesn't have a coefficient, but actually, what's any number times 1? It's that same number. So 1 times x is actually equal to x, so the coefficient is actually a 1. So really all variable, if there's a variable involved, there is a leading coefficient, and if you don't see a number, it means it's automatically a 1. All right, so let's look at these, this expression. The first question is, how many terms are here? Well, we have one term, second term, and our third term, right? Remember, those signs in front of the number belong to that particular term. So we have 3. All right, what are the coefficients? Remember, coefficients are numbers that are attached to a variable. So our coefficients are 3 and 5, 3 and 5. And finally, they're asking what is the constant, and the constant is by itself without a variable, but that sign belongs to the 2. So if you said the constant is 2, that's not right. It's -2 or -2. So you need to know that vocabulary, everybody. Make sure you go back and rewatch it if you need to. All right, so here we have 5 expressions. The questions are, how many terms are in the expressions, excuse me, and also list the variables. I cannot read, you guys. I don't think so. List the coefficients. So I want you to pause the video, and I want you to answer these questions on your own and then come back. All right, did you answer them by yourself? I hope so. So how many terms are there? We have 2x, we have +3x, and we have +7. There are 3 terms. What are our coefficients? Our coefficients are 2 and 3. 7 is not a coefficient, it's a constant. The second one asks how many terms are there? We have 1, 2, 3 terms. What are our coefficients? We have 6 that's multiplied by w, 12 that's multiplied by w, and 3 that's multiplied by z. Number 3, how many terms do we have? We have a +4. We have a +2y, we have a +2, and we have a +10y. So we have 1, 2, 3, 4 terms. What are the coefficients? The coefficients are 2 and 10. That's it. These other 2 are constants. Number 4, how many terms are there? There are 2 terms. What are the coefficients? Did you remember if you don't see one, it's a 1? So the answer is 1 and 8 are the coefficients. And then number 5, how many terms are there? We have 2a, we have +3, we have +4a squared, we have -2 or -2, we have +12a squared, and we have 8a. So how many terms? 1, 2, 3, 4, 5, 6 terms. What are the coefficients? 2, 4, 12, and 8. Did you get them all right? Give me a high five. Good job. Good job. Good job. How you feeling? I bet you're saying, I got it, dude. All right, so you will need to, this is a great video for you guys to come back and watch. putting words, using words in math to describe variable algebraic expressions, and also the opposite, taking algebraic phrases and turning them into expressions. Maybe I said that twice, but vice versa. You're going to need to do both of those things, okay? All right, so these are all different words that represent addition, subtraction, multiplication, and division. So I think I'm going to actually wait on talking much more about this until Monday. Okay, so I'm moving on through this. I'm moving on through this. So y'all move along with me. We'll focus more on this next week. All right, but for today, we're still talking about identifying like terms, and we're going to start talking about combining like terms. All right, so look at all of these up here. How many terms are there? I mean, there's not separated by plus symbols, but these are listed individually. Okay, so we have 7x as a term, 1x is a term, and negative 2x are terms. And there's three terms, but they're actually all considered like terms. Why? Because they all are multiplied by x. And actually, if you don't see an exponent, it's also a 1, just like the coefficient is a 1 if you don't see it. So all of these are multiplied by an exponent raised to the first power. That makes 7x and x and minus 2x all like terms. Now, these are examples of 3 unlike terms because they don't have the same exact variables and exponents. And then down here it says they are unlike terms because the variables and or their exponents are different. For example, the following are all unlike terms. So even though the coefficients are the same, it doesn't matter. It's about the variables and the exponents. These are unlike terms. All right, so this is a great video by Mr. Math Antics about combining like terms. Actually, that comes later. But anyway, this is a good video about identifying polynomials, which is what fancy way of saying what we've been talking about. It's just an expression with multiple terms. All right, so now we are going to talk about adding and combining like terms. So when you do have 2 terms that are like each other, you are allowed to add or subtract those leading coefficients, okay? So look at this whole expression. They're showing you that our like terms are 3x and 7x. Constants are always considered like terms. So 6 and 3 are constants and they are like terms. So we're actually going to combine 3x plus 7x. So if you have 3x's over here and 7x's over here, how many x's do you have? You have 10 x's. So 3x plus 7x is 10x. And then we have 6 plus 3 is plus 9. Now we've taken this expression and we've simplified it down to 10x plus 9. There's nothing else we can do. You cannot add 10x and 9. They are unlike terms. So we've simplified it down as far as we can. We have no idea what the value of x is, so we can't do anything else. So that would be my final answer. All right, so let's look at this long expression. So we're going to simplify the expression. That simply means combine like terms. So we're going to look at all of the numbers that have a, no, no, yes, and I am including the sign in front of it. All right, what about my x's? Do I have more than one x? I have 6 x's here, and I have 5 x's here. And then we have one that is going to be by itself because it is a constant, and constants don't get to be added to a number attached to a variable. So when we add 3 apples and 2 apples, what do we get? We get 5 apples, right? When we have 6 x's over here and 5 x's over here, how many total x's do we have? 11. You have to put either a plus or minus sign here. If everything's plus, you're going to use all pluses, okay? So 6x minus or plus 5x is 11x. And then plus 4 has to be included in the answer because it stands by itself. So we have simplified that expression. There is nothing more we can do to that because everything else is unlike terms down here. All right, and they identify it with all these different colored thingies here, circles, squares, triangles. And they got the same thing we did. 5a plus 11x plus 4. That is the simplified answer. Now this is Mr. Math Antics talking about combining like terms. It's a good video for you guys to watch, give you a lot more video or examples to look at. So I think you should take the time to watch that video. All right, so now this is the last slide we're going to do, but you're going to need much more practice. So like I said, I do want you to go back and watch that video on the previous slide. All right, so I want you guys to pause the video. I want you to practice doing these all by yourself and then come back and check your answers with me. All right, what did you guys get on the first one? 2x plus 3x plus 7. We're going to add 2x plus 3x, and we get 5x, and then positive 7 is part of our answer. All right, I don't like that color. Let's change. What about the next one? We have some W's. We have 6 worms and then 12 more worms. How many worms do we have? We have 18 worms. Plus, we have 3 zebras, and zebras and worms don't go together, guys. They're not like each other, right? Yeah. All right, right down here, we have a 4 combined with -2. That's why it's so important to make sure you circle the sign in front of it, because if you just circled 4 and 2, you might add 4 plus 2, but it's actually telling you the problem is 4 minus 2. 4 minus 2 is 2. And then what are we going to do with those y's? We have 2 yo-yos and 10 yo-yos. Don't we have a total of 12 yo-yos? Absolutely. And by the way, if you wrote this in a different order, if you wrote 12y plus 2, you've used the commutative property, and that will tell you that you have an equivalent expression that I do. Same thing here. If you put 3z plus 18w, you still got the same answer. 7 plus 5x is the same. They're equivalent, right? All right, now this one is a little tricky because we know this is 8a, or 8 apples. How many apples is this? This is 1 apple by itself. So what do you think 1a plus 8a is? Hopefully you got 9a. I bet you did. All right, now we got this really long one. I'm going to start with the a's. So 2a is not the same as 4a squared, right? So all we have is 2a plus 8a. So that's 10a. All right, then let's just go in order. We have a positive 3 combined with -2. What is 3 minus 2? 3 minus 2 is 1, positive 1, right? You have to put a plus symbol if it's positive. And then what do we have left? We have 4a squared plus 12a squared. We're not adding those exponents. We're just adding the coefficients. So 4a squared plus 12a squared is 16a squared. Whoops. And guess what? We have simplified that expression. Okay. All right, guys. So I think that's all I have for today's video. Yep, we'll start with the distributive property next week, and also we'll use the variables to write verbal expressions and all that stuff as well. So if you guys need any help, please let me know. I hope everyone has a good rest of the week, and I will check on you guys soon.